All right, so this project is for Terex Corporation. We designed a pick-to-light system for their assembly process. So the assembly worker can quickly and easily find the right parts to pick from their parts warehouse. We've got the electronics bar showing how many parts and where to pick from. So it's very simple, it works.
Our project was to find the pressure between seals for Caterpillar. Their main concern was that most 17% of their warranties were paid out on seal failures. So with this project, we were hoping to come up with a sensor in order to measure a pressure between the seals dynamically. And what we came up with was this Texan system, which is a resistive material, piezo-resistive, and basically by pressing on this, it changes the resistance of the sensor, and it brings it up here as a wire or as a value, and then we can then calibrate that value to give us the actual pressure and force of whatever we're trying to measure. And with that, they're hoping to be able to tell when a seal fails, how it fails, and to get a little bit more information on it.
Our in-vehicle fixture for on-road data acquisition. It's designed to sit in the passenger seat of a vehicle. We have some power inverter and a splitter to power up to 4 of these LMS data acquisition units. The laptop will sit on this platform here, which can move back and forth. It's also rotate to provide the user with a good view of the screen. And also so the screen is level when it's in a vehicle because the seat is actually inside. We have a kickstand leveling feature to provide a level workstation when it's outside of the vehicle.
Alright, this is our mistake-proof visual market supermarket system, and what this is it's a storage flow rack for storing small parts for assembly and hydraulic fittings. How this works is we have these LED displays with push-to-brake buttons that's hooked up to a computer that runs an Excel database. A user will come up to the computer, plug in a build code number, and then these LEDs are going to light up to the corresponding bin that he has to pull parts from with the number of parts he has to take from each one. Once he's successfully taken his parts out of each bin, he'll push that reset button, the display will go black, and he will go on down the line.
Well, we were developing 4 thermal science experiments for the mechanical engineering department. Undergraduate students take this course in their junior year. And the 4 experiments that we developed, there's a mechanical equivalent of heat here. Students turn a crank and do a bunch of work, and then the apparatus turns the work into heat. We're able to measure the temperature difference and see the equivalence of heat and work there. We've got an experiment here where we conduct some experiments on the efficiency of a water heater, and then also run through a tube-in-tube heat exchanger and look at the effectiveness there. We've got an experiment where we run water through a nozzle. We take measurements of the pressure inside and the thrust that it produces. So this would be similar to like a fireman trying to hold onto a hose, something like that, and look at what's involved there. And then we take the things we learn here and we apply it to a rocket with water coming out of a nozzle, very similar, but a little bit more, the mass is changing and there's more variables. Study the trajectory of the rocket, things like that.
So
this is the device itself. So we've got the water heater, the heat exchanger right here, some flow meters, pressure transducer on the back here. This is the water comes out and causes some bending in this beam. We measure that deflection.
Caterpillar wanted their oil leak measurement system. So basically, they have this setup here, which is called the VS Cube. What they do there is they use these metal face seals. They test them. So basically, they help to use dynamic sealing. So one of them is stationary, the other one is rotating. So these surfaces are really polished, so they make a dynamic sealing. As they wear out, oil leaks out. So they want to know how much is oil leaking at this, on this sealing interface. Basically, these test setups that they have for testing seals can do pretty much everything, except that it can't measure the oil. So they wanted a team or project that could actually measure oil. So our team developed two different systems. One of them is a SOLIC method. Actually, it's called seal oil leakage image calibration and quantification. So this is a calibration piece for the whole system. This is a MATLAB software that uses the same kind of system and quantifies the oil. And the other measurement system is a capacitance measurement system. So difference between two is that this uses digital images. So we take a picture of the oil leak. Here you can see the oil leak. This is the oil leak. So basically, we add UV dye into oil, so it glows under the UV lights, fluorescent lights. We add a dye, take a picture of that, so this is a picture of the oil leak, or you can also see those here. Take a picture of that, upload it into MATLAB, and using intensity thickness curve, we are able to get these values. This is a plot of oil leak. So basically, yeah, this is based on the image processing. Another one is a capacitance measurement, where we apply a capacitor on a seal flange, just like this. And as oil leaks out and sticks to capacitor, and this capacitance measurement measures the capacitance, and we can say how much oil we have on that capacitor there. So those are two different systems developed.